Welcome back, everyone, to On.net. I'm your host, James Montemagno, and today we have a special Python edition of On.net. That's right, Python. Well, if it's something Python related, you know I got my good friend Tony Baloney, Mr. Anthony Shaw. How's it going, buddy?
Hey, James. Great to be here.
Now, I know that it's a Python related episode because when you reached out to me, put it in the form, every single link was Tony Baloney this, Tony Baloney that. People don't know why I'm Tony Baloneying you. That is your GitHub username, correct?
Yeah, it is and has been for a very long time. I don't even remember why. It rhymed. People kept calling me Tony, even though that's not my name. Baloney kind of in English, and I think American as well, means kind of not very good. So yeah, it was just a bit of a tongue-in-cheek rhyme that I picked a long time ago. And then as I've slowly become more professional over the last 10 years or so, I'm sticking with it. I'm not changing it here.
That's good. Yeah. It's always fun when childhood nicknames stick with you for a while, or even just early in career nicknames. My nickname forever is Motz, M-O-T-Z, is a very shortened abbreviation of my last name. And I always wanted to get that username. Tony Baloney, obviously, I think a little easier to get, but Motz, which is also common, last name of Moats is spelled. Someone always has it. So it's hard to get a 4-letter name. So I needed to do a little bit better, but I'm just generic at James Montemagno everywhere. So it's not as cool, but Anthony, I like you. I'm excited. If people don't know why we're talking about Python, Anthony, why are we talking about Python and .NET? What is happening here?
Oh, well, Python. Yeah, so I'm the Python advocacy lead at Microsoft. I am Python through and through. I did in a past life do quite a lot of .NET, and more recently I've done a lot more. It's been super confusing switching between.
Reeling you back in.
It's been super confusing switching between .NET and Python. I keep typing semicolons in my Python and editing them back out again. So yeah, we talk about this because Python has exploded in popularity over the last 10 years. And one of the major reasons for that is that there's kind of a momentum of packages built for Python that are written for machine learning, data processing, astronomy, soil science. So any kind of scientific field, there will be a really interesting, mature package for Python written for that. And mostly that's because people have got this exploration environment called a Jupyter Notebook, and researchers, scientific researchers can play with data, do experiments, get graphs, charts, stuff like that. And that's kind of picked up and become really popular. It's really cool. It's a nice technology. The fact that it's written in Python just kind of makes it easy, convenient for people to pick up. A lot of that stuff beforehand was in MATLAB and other different languages and tools and stuff like that. Mostly proprietary or very expensive, and the universities would pay the licenses. But nowadays, everyone's got access to this open source stuff, and it's all in Python. They can use it in Jupyter. So Python has kind of exploded in popularity. And then this AI thing.
I've heard of it. Yeah.
Come on the scene. We don't talk about it much. We should talk about it more. So yeah, AI has kind of come around, and most of the backend for AI is written in Python. So the training, the algorithms, the data processing, the preparation of data to feed into the models is all Python. So it's Python all the way down. Almost all the way down. You get right to the bottom and it's actually C, but it's pretty much all the way down.
Isn't it always at some point? Yeah.
Yeah, I mean, it's the same as .NET. I've done a little bit of work on the .NET compiler and the runtime, which is all in C++. So it's .NET almost all the way down, and then we switched to another one. So yeah, that's why Python has kind of become really popular. And the more I talk to .NET developers, customers of ours, or just developers in general, they've built these big applications in .NET. They've got a lot of integrations on the auth side. They know how to write microservices. They know how to do all the instrumentation. They've got huge projects, and they're I just want to use this one package or this one library, and it's impractical to rewrite that in .NET because often these packages, you look at it and you look at the code and think it's not that complicated, but it's got 50 dependencies, and then it's okay, if you write that from scratch, you've got to figure out how to do it and stuff like that. So what we wanted to do was to make it easy for people to take a package or like some Python code and then just embed that in their .NET program.
No, I like that. That's sounds like the dream. Like, I think that especially me coming from my Xamarin and now Maui background, right? It's like, I want to use some Objective-C or some Java stuff like in my C# .NET app. Like, I just want to use that library over there. Let me just get it, right? So that entire, analogy makes a lot of sense to me. And like, yeah, you're right. Like in the world of AI, there's like tons of libraries, right? That are out there in Python. And Dawn on my team is always like talking about this package and that thing. I'm like, I would like to use that. So you're saying that there's something out there that would enable me to do this, Anthony?
Yeah, there's something out there. We put it together.
Not me. When you say we, I had nothing to do with this. It's not me. Not me.
Yeah, we've made this. It kind of came around at Build this year. I was nerd sniped by someone on the .NET team. They said, if you would integrate Python into .NET, how would you do it? And then after going into a long explanation about how I would do it, I realized that I'd fallen for the trap. And I then had to sit down and write this thing. So, we've basically got this project ready for people to have a play around with. And we're kind of taking feedback and stuff like that. And I just want to share it with people and see, what they can make with it and what they want to use it for. So, yeah.
Well, let's take a look. Let's get your desktop up.
Okay, so we've been working on a tool called CSnakes. It is a bit of a pun. We're embedding snakes, which is Python, into C#, so that's where we got the name. And it is a NuGet package that you install into a .NET project, and then you can drag and drop Python code into the project, into the solution. It will analyze the code and then create an interface for you to call any functions in that Python code. And it handles the interrupt, like the marshalling of the data in between Python and .NET. So it's a fairly low-level integration. Like you could do something like this already using like a REST API or something like that. But the challenge with putting a REST API on top of Python and then calling it from .NET over another REST interface is that you've added like 2 additional layers, and you've then got to figure out like how do you do the auth between the API endpoints. Like you effectively need to use something like microservices to do this today. And you lose a lot of information like tracing and auth. So we wanted to run Python in the .NET process and handle the marshalling of data between Python types and .NET types, because there are some pretty important differences between like dictionaries in Python and dictionaries in .NET, for example. So what we've got are a simple diagram. You've got your Python code, you have your functions in Python, and Python is dynamically typed. It does have types, under the covers, but you generally don't need to tell Python what type something is. To make it a lot easier and less stressful for people to integrate the two, we're encouraging people to annotate their Python functions. So this is a feature in Python. You can just say, this variable is this type. We actually use that information to help auto-generate this class. So we've got a source generator. The source generator is optional, but if you've got a Python file in your solution, you can mark that for the source generator, and it will then automatically build like an interrupt class. This is similar to like the newer library import, like the meta information, how that like auto generates interrupt code between C# and like C or C++ bindings. You've then got the Python dependencies, because just the code itself is not enough. You need to also have the Python runtime. You need to have the packages and dependencies. So we've written a bunch of tools to help you like discover and build that environment and load it into the Python process. And then when you run the code, it's running in the .NET process, but we've got to handle the communication between Python's garbage collector and the .NET garbage collector, and how Python quite famously has this like global interpreter lock, which means that only one thread can run at a time. So we manage that, because in .NET, people love making managed threads and running them all concurrently. Even the garbage collector runs in its own thread, which is a good design.
Yeah.
But we've basically done a lot of engineering to make sure that that works seamlessly with Python. So this is written for .NET 8 and .NET 9. And we support Python versions 3.9 to 3.13. So .NET 9 is not out yet, and Python 3.13 is not out yet either. So we're on the
cutting edge.
We're absolutely cutting edge. I'm testing releases that came out like last week. So yeah, this is kind of the idea of our project. We've also done some interesting work with because I talked about like why data science is one of the big reasons why Python has become so popular. We focused a lot on that use case because that's what we're hearing from developers and customers about the kind of things they want to integrate is really around like the data science, ML, and AI. And those types of integrations, you tend to have a lot of the data that you're marshalling in between would be like lots of arrays or matrices. And the types inside of those would typically be like integers and floats. So we've actually just also added an integration between, so NumPy is the sort of n-dimensional array framework. It's a linear algebra framework for Python, but it's used in, if you use any like small language models, for example, or you do any kind of ML or AI work locally, then you're normally passing around these NumPy arrays. They're essentially matrices with the training data or the results data, like all of that sort of thing. And we've basically built an integration between those and the span interfaces in .NET 8 and the tensor span interface in .NET 9.
Oh, cool.
So if you have a one-dimensional or two-dimensional array in NumPy, you can actually access that directly from a span. So it's actually reading the memory in the array. There's no marshalling, there's no copying. You can basically access that. So the performance of that is extremely, extremely fast. And then more recently, we just did the tensor span integration. So if you've got, you'd often do this in machine learning, like training cycles. You've got these kind of big matrices of floating point numbers, for example, 32-bit or 64-bit floating point numbers. And you can access and read those as tensor spans and shared data backwards and forwards between .NET and Python.
Yeah. So do you see basically like in this scenario, you have a bunch of these Python functions, and for all intents and purposes, the class that you're generating is like, hey, you're going to shove a bunch of data into a Python function, and then the Python function is going to spit out a bunch of data objects back at you, right? Or it may not. It might just compute something or do something else, but is it always kind of that two-way street? That's why this sort of type and these marshalling and these integrations are so important, is because there's data going in, data going out, right?
Yeah, we focused a lot on trying to get the marshalling between the two as fast as possible, but it's never going to be as fast as .NET to .NET because when you're doing .NET to .NET, the JIT can do a lot of optimization. Whereas when you've got a boundary between platforms, you need to, store the data into memory in a specific type so that it meets the interface. So there is an overhead between the two. We've been working really hard on trying to get that overhead as small as possible. The span integration is definitely, I think this is pretty much like zero overhead, the span integration, because of the way spans work. You can just effectively access a piece of memory. And that's the same piece of memory that Python is using. But yeah, the way I see this working is you'd have like a handful of functions in Python and you'd call those from .NET. You wouldn't be writing code which is going backwards and forwards all the time.
Yeah.
Because they're very different as well. So, one of the questions is like, if my function returns a class, like, can you convert that into a .NET class? And I've seen projects that have attempted this in the past, but there are just so many differences between a Python class and a .NET class. Even if we did build that integration, it would be confusing for both Python developers and .NET developers. And that's not the kind of experience I want to have in this project.
Gotcha. So would you say like when you're designing your Python functions, then you're sort of trying to design those in mind, or you might create a function that would sort of be .NET ready in a way, right? Let's say, for example, Tony Baloney's amazing, Python package has like all these amazing methods on it, right? All these functions. If I was to use your package directly, would it work, or is it sort of best like hey, what would be great is if James like creates a little sort of helper Python function on top of your function that sort of defines an interface that is sort of .NET aware in a way.
Yeah, I think it's closer to the second one. So an example would be, I guess, like how you would design an API, like a HTTP REST API. You typically wouldn't just expose an entire library as an API. And I'm sure there's plenty of developers out there who've used some of those APIs where they've got a bit too low down with the like, oh, this is our API boundary, and it feels like we're just calling the class like RPC effectively. You need to write a sort of wrapper function around the code to annotate it and just to simplify the communication between the two platforms. So that's kind of what we've done in the demo. Is mostly, when we're using like a library or something, it's like we've written a small function where the parameters are pretty strictly defined. We've strictly defined the types as well. You don't have to do that. It just makes it a lot easier, because if you have a function that says this takes a list of strings, for example, then you can call that from .NET with a list of strings. Like under the hood, it takes a Python object, but we handle the conversion between a list of strings in .NET to a Python object. We sort all that out for you.
That's cool. Well, let's see it. I'm ready to see it. What you got for me?
All right. So I'm going to start with the most basic demo. So like I said before, to run Python in .NET in the process, we need a couple of things. So first of all, we need Python. We need to know like where Python is installed, and then if you've got any third-party dependencies, then we need to make sure that those are installed and set up, and we can access them. So what we've done is we've created a sort of host builder pattern. So what you would do is with your service collection, you can do with Python. It effectively loads the CSnakes project into your service environment. So this quick test is a command line app. This is a sort of like Hello World one, and I've installed CSnakes the CSnakes runtime as a dependency. For convenience, I've also added Python as a dependency, because on Windows there is actually a NuGet package for Python. This just makes it really easy to share with people, because you can basically just build and run this, and the end user doesn't need to install Python because it's already bundled in NuGet. Right. But that's only Windows. So we've also got these locators that are for other platforms. So we've got a macOS one, we've got various different Linux ones, and we'll basically figure out, okay, we found Python, we've linked it all for you, we load the libraries into the .NET process, and then I've also specified I want a virtual environment. A virtual environment in Python is kind of similar to how it sets up like NuGet within a .NET solution, a .NET project. So it would like pull in the packages, but put them inside that folder, so they're not polluting like the global namespace. And then we handle that for you. So when you run this project, it's going to go and install anything I've got in this list of dependencies, which is NumPy, scikit-learn, Wheel, and Transformers. These are the packages that I wanted to use. It's going to go and install those for me, set them up, and then once I've done that, I resolve this Python environment interface. So I get an instance of that. That's a singleton, because you should have one Python process effectively running inside one .NET process. So that is a singleton that you get back. And then in that environment, you can then run any functions in the modules that you've got inside it. So this one, I think, this quick demo one is based off of this module. So it's looked at this Python module here. So the example Python dependency is a project dependency of our command line app. and we've got the CSnakes runtime. So the source generator has looked at the Python files that we've told it to analyze. It's parsed them and looked, okay, they've got two functions, one called scream, one called scream names. The first one called scream takes a string and a length, and it returns a string. This syntax is how we do typing in Python. It is not, it doesn't validate the types. This is something, it's called a type annotation because it's more like a comment than an actual, like a type safety. But we've got extra code to check if you give it the wrong thing.
Nice.
It is as dynamic as it sensibly needs to be, but if you give it a list, then it's going to give you a good error instead of just exploding. And then scream names basically takes a list, so we can demonstrate this list interface and returns back a list. So the most simple Python code I could think of, and in quick demo, we get an instance of the module. In Python, we love the this kind of casing. So this we like functions to be all lowercase. We like parameters to all be lowercase, classes to be Pascal case, and functions to be snake case. So that is how Python developers like to write code. .NET is very different. So typically, we use Pascal casing for interfaces classes. Local parameters or local like variables and stuff like that tend to be Pascal case but lowercase on the first word. So we've done that for you. So it's called Quick Demo because that is the Pascal version of that same module. And then on the interface, I can see the two methods. So we've got scream, which is the function that takes a string and a number and returns back a string. So that one, you just call that from .NET and it runs the function within the process, and it handles the conversion of a .NET string into a Python string and a .NET long into a Python integer. And then similar to this scream names one, takes a list and returns back a list. This is a read-only list in this case, but we're basically handling the marshalling and the conversion of the information between .NET and Python.
Very cool. Yeah, it makes all sense to me. I mean, that like this code, right? If anyone was to give this to me as a package, it would just be a bunch of methods that I could call. Yeah,
exactly. So, yeah, the idea is here that you can compile that, you can bind it, and you've got all the type safety. You're not. I've seen other integrations where you need to put the name of the function in quotes, and it resolves it at runtime and stuff like that. And it's difficult because it's harder to test it. It's hard to do CI in those types of environments. So really here, what we're doing is we're kind of creating those bindings, and we've got all the safety underneath that. So, if you rename the function, for example, then it is going to tell you that it can't find it. But yeah, we've done that integration for you. So then the second one, because this is a quick demo, but multiplying a string by a number, you can do that in .NET. So, it's a bit unnecessary, but it's just mostly showing how you can call backwards and forwards between the two things. The second one I wanted to show you was this one. This is a bit more realistic in terms of what you can do. So SKLearn is a library that has a lot of ML and AI algorithms that have been written by experts, and they're exposed as functions. So if you ever want to do any kind of classification or training regression algorithms, any like data analysis and stuff like that, often you'd use scikit-learn as one of the tools to do that. And one of those algorithms is the k-means algorithm. It's kind of a classification grouping algorithm. And this function is similar to the question you asked before, which is, would you write like a helper function around it?
Mm-hmm.
And I think you would, because this function, I mean, I don't know if you can see that type signature, but
wild.
It's pretty wild. And this is a pretty good one.
Yeah.
I've seen things like pandas, for example, NumPy. Like this takes something which is matrix-like, which in itself is like a reference to another series of types. It returns either a tuple of 3 values or a tuple of 4 values. So that in itself is extremely difficult to describe in .NET. There's no unions, for example. I can see at least 1, 2, 3 unions in that type signature. So kind of if we just generated a function for this and gave it to you in .NET, you would have to do a lot of working out as a developer to figure out how do you call this function. It's not obvious either. Like, okay, what is matrix like? So this function that we wrap around it, we create a NumPy array from the data. And in my type, I've said, this is a list of 2-value tuple. So the tuple of 2 integers. So it's effectively a 2-dimensional matrix, or it's a list of 2-dimensional matrices. And then we ask for the number of clusters. So I've simplified the call to this API. And then I've also simplified the result because, like I said before, this could return a 3-value tuple or a 4-value tuple. That would be a nightmare to work with.
Yeah, I can't imagine.
So I've converted this back into a list, effectively like a 2D result of floats. And I've also included the second point, which is the inertia, which is the thing we're kind of calculating with this algorithm. So when we run that from .NET, then we can work with simpler types. So here's our matrices. So we can describe that in .NET. And then when I call it, I can see that takes a read-only list of long tuples. It takes a long of clusters, and then I can get that result back pretty straightforward. So that's kind of how we work between the two platforms.
Yeah, it makes a lot of sense, especially when you see those signatures and those unions and the complexity that goes in there. This is something that makes a lot more sense coming from the .NET world. So it's like really crafting that API that will more closely align for simplicity's sakes for when you actually want to do something. Because if you need more, then you would just kind of create more functions or more functions that take in different parameters, but you're simplifying the output here, which makes a lot of sense.
Yeah, definitely.
Cool.
Yeah, so that's kind of our most basic demo. We were showing you how to run NumPy SKLearn in a .NET process. And then I can show you something a bit more.
You got to run it. You got to run it. I got to see it,
sorry.
Anthony. You got to run it. And we're going to see other demos too, but yeah, I'm ready.
Let me rebuild and run it.
Because I got to see the proof of it actually running. So now in this case, right, you're on Windows, so all you did is take down that package. Else, if you had Python installed, you would just point to where Python's at.
Yeah, it would figure it out for you. We've got a locator for the Windows, the Microsoft Store, not the physical one, the virtual one, and the and like the Windows installer as well. So if you had any of those things. So yeah, it's running backwards and forwards. The k-means algorithm is running now. That one actually takes a bit of time, but you just come back with the clusters and the inertia. And then I've got another demo in there, which I haven't actually set up on this environment. It does like GPU modeling to run the Phi-3 small language model.
Cool.
But that one requires a whole bunch of stuff that I don't have physically on this machine. So you need a pretty serious GPU to run that. So yeah, it's run it. It's also like when it started up, it's made sure that the packages and the versions and stuff are installed and running. You typically only do that once. So if this is a service that you're running or you're making like lots of calls, then because it's a singleton, then we run that kind of process once to make sure that all dependencies are set up and configured. Because package management in Python is a whole beast in itself. So we're really trying to make sure that that's simple, especially from a .NET developer. You don't want to have to learn packaging for Python because it's a whole topic.
I've already learned it. I can't go back now. So
yeah, you can't unlearn it.
But this is nice because honestly, like as a C#.NET developer, like actually working in this world, even if I wanted to just like maybe deploy something that was just Python, I would actually prefer to work in this world because I normally am just using Python, like you said, when I need to expose one or two methods from a really cool library. So this is cool to see, especially the the k-means one as well. So what else you got for me? I'm ready.
All right, so we're going to turn it up a little bit. And so here we've got an Aspire application. And in our Aspire app, we've got a HTTP endpoint. We've also got something else. I don't know if have you ever done this before, James? You've added Postgres into Aspire.
Mm-hmm. Oh, yeah.
So this is pretty cool. So often if you've got a database, like for the application, and you want to use Postgres as one of the databases, you can inject Postgres into the Aspire environment. This is nice because when you're developing locally and you want to test things out, then like installing and running Postgres either in a Docker container or actually like installing it on the machine is a bit of a faff. So like there's quite a few things you've got to do. You've got to set up all the auth and things like that. So what you can do in Aspire is you can just add Postgres as a service, give it a name. You can add the PG admin, which is like the web interface for managing Postgres. And then you can also add a database. So like in our app, we've got this weather database with some weather forecasts. And then we're also going to add the API endpoint. So we've got an API in here. And then we've got like a simple web app as well.
Nice.
So we've got just a couple of components. We've got Postgres, an API, and a web app. So let's look at the API. So the API, I'm doing something very similar to what I was doing with the command line application, but here as an API. So, there's a big difference between a command line app and a REST API, because in a REST API, you've got multiple people calling the same thing at the same time. You've got, it's going to spin things up in thread pools. It's got things running concurrently. You've got like coroutines in there. There's a lot more complexity to that type of application. So we've been working on this demo because I think this is kind of a more realistic way that people might add a Python component to an existing API endpoint for .NET. So the bulk of the API is written in .NET, and then we've got like one route which is running in Python. So similar to what we did with the other one, we inject Python into the process, so we add it to the service environment. We've got some packages in there that you need to install, and then we add the singleton for the Python environment into there. We've got some little code in here which says if this is in development mode, create a whole bunch of like fake data in the database, so that when we launch the application for the first time, we've got some like records in the weather forecast database.
Nice.
So that one there, that function, we resolve the weather interface. So this is something that's created by the source generator in CSnakes. So we've got that interface, and we know that interface has a method on it called seedDatabase. And similar with the command line app, we're going to look at any functions that we've defined in our Python code, and then generate the type signatures. So we've got this one called seedDatabase that doesn't take any parameters, doesn't return anything. But from Python, it's going to generate a whole bunch of dummy data and then write it into the database. So I've got my SQL statement in there. I'm going to connect to Postgres, and I'm going to call that in and execute directly.
How does it know about Postgres in this instance?
That's a good question. So, in Aspire, when you add Postgres as a service, it will also add the connection string in the environment variable of the process. Mm-hmm. So what we've done is we grab the weather forecast connection string from the os.getEnv is how you read environment variables in Python. Mm-hmm. We read that. It's an ADO connection string. There isn't a library for that in Python, but they're quite easy to parse. So we just added a bit of code in here to read that connection string and turn it into a database name, a user, and a password.
Nice.
And then using something called psychopg2, which is a Postgres client for Python, we just connect into that database. So you can connect to that database from dotnet, you can connect to it from Python. It's the same database, same instance. So we can write effectively to the database from Python, and you can just call that function from the .NET code.
Cool. That's awesome.
Cool. So that's how we do that component. Where was I? There's too many files called program.cs. So yeah, that's our one that we have. If something goes wrong in there, so, we've got a Python exception gets thrown. We take that exception information, like the stack trace, the parameters, if it's like a nested exception, and we throw that back up as a CLR exception. So you can catch the Python exceptions. You can see all the trace information. You can see everything on the .NET side. So,
Cool.
we never want you to have to break into a Python debugger. We just want you to stick within the .NET environment and not have to kind of manage the two. And then the next thing we did is we added a weather forecast route where we call the get weather forecast, which is this one here. This returns a list of dictionaries. So we're getting a little bit more complicated with our typing, but the key is a string and the value could be anything. And the dictionary is basically we're reading some information out of the SQL database and we're returning it back. So yeah, this is kind of working between the two. The reason I've got these extra parameters, trace ID and span ID, is because I'm also adding instrumentation using OpenTelemetry in this application. So when I run it, because Spire kind of integrates really nicely with OpenTelemetry, we've got this Spire, the dashboard as well. So I want to get that trace information from Python. So if there's any errors and stuff thrown in the Python environment, I want to see that as part of the request span that was in the .NET environment. I don't want them to be two separate things. I don't want to have to look at like the logging for Python and the logging for .NET and try and work out which one belonged to which request. So effectively, we're kind of like bridging that boundary by using OpenTelemetry, because that's what OpenTelemetry was designed to do. You've got distributed tracing. So I can get that weather forecast back. It gives me back a list of dictionaries. And in my list of dictionaries, some of those are like, some of the values in the dictionaries are strings, some of them numbers. It's kind of a bit of a mixed bag. So I can access it like a dictionary because I've told it that the key is a string. So like it knows that F is a dictionary and I can access any of the keys in there using a string. And I can run these conversion methods. So like I've got as long, for example, here because the temperature in Celsius, we've been using Celsius in here, not Fahrenheit, but temperature of Celsius, we can convert that back into a long, and it will handle the conversion in the type method.
Cool. It's really neat. It's almost like it's a big dictionary bug, but almost like a JSON parsing things out in a way of this, somewhat of just a Python object that's coming back. So sort of like, it reminds me of just like generic JSON parsing where I don't know what it is, but like I do know what it is. So like, I'll tell you what it is.
Yeah. And we've done that lazily as well. So, if you get back a dictionary from Python, we're only going to do the marshalling on the keys if you request them. Because that is a fairly expensive operation. Like they're effectively lazy dictionaries. And we do the same with lists as well. So, if you only want to get the length of a list or the last item, then we're not going to marshal the whole thing. So we just do that at runtime.
Very cool.
All right, let's give it a spin and see what happens.
Yeah, and this is kind of interesting because you are just like literally using that Python file directly from that same exact backend code. There's like you had it in the console, now it's in the API project. It's like the same exact one, which is cool. Yeah.
Okay, let's make that bigger. Cool. So I've got my dependencies. I've got Postgres. I've got pgadmin, so that sort of management interface we talked about. So I don't really need to use pgadmin because I've already said, I've created a database for me and it's set that up. And then we've got the database resource. So in Aspire, it would, because I've asked it to have a database as well, then that's a component that's in the service environment. I've got my API service and I've got my web front end. So if I look at the web front end, I can see just some basic information. But if I click on weather, that's coming from Python. So that code that just happened in the blink of an eye was the Python execution. So it's coming back and it's reading from the database and it's converting that information into a dictionary. And then from .NET, I'm getting that result and printing it back into the environment.
Very cool. Like, that's pretty astonishing because it was pretty transparent from, like, if someone gave me that API, right? It's just like, oh, get the weather, get whatever. And the cool part here, like, I want to kind of point out is, like, in that code, yeah, it is calling into a database and it's doing tracing, I assume, too. But it could be doing a whole bunch of data science-y things as well and returning that as well back into it if you're just wanting to add some more Python power into your APIs, for example.
Yeah, so if we wanted to do some like trend analysis for the weather or actually make it like a predictive weather forecast, we could have done that inside the Python code. And that would be like a good use case because we're reading from the database. The database has been set up by Aspire. We can look at data backwards and forwards between the two platforms. But I just want to return back a summary set from Python and then parse that back up through the API. So in terms of the structured logs, then we've got anything that I do in the API, I can see in here as well. So let me find an example. So in my Python code, I had logger.info. So this is Python logging. But in my application, I've told the Python logs to write to OpenTelemetry. So like the generating weather forecast, like that logging method is this one. And that belongs to the same trace. So we've got, you see the trace ID coming in here from the web front end. That trace gets passed all the way down. So I can see any log records I make in Python are captured under the same trace. And then we've also got a span. So in the span, we can filter in the logs, so we can look at that and we can see, okay, I made a request to the web app. That then came down into the .NET stuff. That's resolving on the API. And then I've got this other span called generate forecast, which is this code here. So I'm in Python, I've generated a span, and I've added some span context. And OpenTelemetry in .NET and in Python, you can like install all these extra instrumentation libraries. So I've got like an instrumentation library for Postgres specifically, and it's got this cool feature called a commenter, and the commenter will basically add like span attributes to say like, oh, this is the SQL query you were doing. So like that is the SQL query inside Python and being captured in the same trace. So I can see everything in here. I can even see like the SQL statement that got run, and all my information. So if one of those components crashes, explodes, does something weird, I can see that in my span and in my trace.
Well, I think what's cool about that too is that, a lot of people might come in thinking, okay, I'm going to use this and everything's going to kind of feel like it's glued together, like tacked on, right? Like it's not integrated. But what this shows is that basically because we're able to, use OpenTelemetry in this case, but also get this data back and forth between it, you can still have a very seamless sort of development environment setup that can help you walk through what's happening in your applications.
Definitely. And because we're embedding Python in the same process, then, I've got this API endpoint running. And in that project, I've included a JMeter test for anyone who's into load testing. So if you want to go and smash that with like 100,000 requests, it will quite happily sit there and respond to all of them with a concurrency of whatever your CPU can handle. So, we've worked out how to do that kind of concurrency and parallelism. And there's something exciting coming out in Python, the new version of Python, which is out in October, which is where you can turn the GIL off. It's super experimental, but it's a pretty well-hyped feature of the new Python called no GIL. Effectively, you can run like truly like free threads, like proper parallel thread execution in Python. And we support that as well, even though it's like super experimental. So you can turn the GIL off in Python in the new version. We do support that, but the ecosystem in Python is still trying to catch up to that feature because it hasn't really been released yet.
This is super cool, Anthony. I love it. Anything else you want to show off before we get out of here?
I think that's the gist of it. If you're interested in this, check out the CSnakes project on GitHub. And where are we? Yeah. Have a look at the website, have a look at the documentation, check out the sample projects. And in the GitHub project, feel free to go and log any issues or give us any feedback and anything like that if you bump into it. We're just really kind of looking for feedback from .NET developers and Python developers about what they've been making and how things have been working out. So yeah, that's my call to action.
Well, thank you so much, Anthony. This is awesome. Obviously, people can find you on GitHub at Tony Baloney. Where else can they find you, Anthony?
You can find me on X. You can find me on Mastodon. You can find me on LinkedIn if you want to as well. But yeah, check it out on GitHub and let me know what you think.
Nice. LinkedIn, that's where I hang out as well. Well, I'll put links to everything that Anthony showed, to the CSnakes project, to all the samples, everything else like that. And definitely make sure you tune in, because Anthony's going to go even deeper, if you can imagine, on CSnakes at .NET Conf happening in November with the launch of .NET 9 and whatever new crazy .NET 9 and Python ridiculous awesomeness will happen before then in this project. So Anthony, thank you so much for coming on. I really appreciate it.
Thanks, James. It's a pleasure.
Awesome. And thanks to all of you for tuning in. And don't forget to do all the things that I tell you to do at the end of every single video, because it really helps out this video, this channel, and everything. So if you like this type of content, give it a thumbs up, put comments below, because Anthony will be laser focused on answering every single one of those. Check out the GitHub project, ring that notification bell when you hit subscribe, so you stay up to date every single time we put out a new video right here on the .NET YouTube. So until next time, I'm James. Thanks for watching.